side of the lake is the fact that the thing probably came from the south toward the north, approximately. So the smaller things, because of the atmosphere, fall first, and then the bigger things make it through the atmosphere a little bit better. And there was a question.
Same question.
Oh, all right. Would you like me to answer it again? No, no.
This lady had one first, actually.
Yeah.
Sorry.
Oh, yeah.
During the video there, you were holding various specimens, and you said this is an H4 or an L5. What does that mean?
So basically, these are all what are called ordinary chondrites for like 95% of all the meteorites that have fallen to the earth that we have collected are basically silicates. They're rocky, stony meteorites. That's why they're called ordinary. And a lot of them contain what are called chondrules, which are melted spheres of material, more silicate material that melted at the very time that the solar system was formed. So they're called ordinary chondrites. All of them contain some amount of iron, and L implies low iron, and H implies higher amount of iron in the silicate material, in the minerals.
So that's like a saturation classification? How many of the chondrites are?
It's the amount of metal
it's
in
the
there.
amount of metal, so it has nothing to do with the chondrites. It's a separate classification. So basically L implies low iron and H implies higher iron. And the number has something to do with how much it's been heated probably on the original body. So something like that's like an L3 or H3 or whatever it is will have more distinctive chondrules in it, where something at the 5 or 6 or 7 will have been heated somewhere early on in its life. And so you won't see as distinctive or as many chondrules in it.
Thank you.
Terry, I saw your hand up.
You may have answered it. So when you're using the metal detector, is it iron that it is detecting, or?
Okay,
Nickel.
so the H and the L have to do with the iron that's actually incorporated as part of the minerals in the, whether it's pelagic clays or whatever it might be, olivine. If you look at the meteorites in the back and hold them and move them around, you will see little specks of iron, and that's iron nickel. And those are the first things that condensed out of the solar system. When the solar system, the nebula, was condensing out to make the protoplanets and then the planets, basically the iron is the first stuff to have condensed out. And so what you're seeing is literally the first condensates, the raindrops, whatever you want to call them, when the solar system formed about 4.567 billion years ago, give or take a few million years.
I have another question on top of that one.
Okay, we'll let you go ahead. Go ahead.
So you said it dispersed about 15,000 years ago, but what would the age of the actual piece have been in the solar system?
Okay, so the ordinary chondrites formed into the original asteroids in the asteroid belt 4.5667 billion years ago, give or take a million years. With a B. I think the age of the actual breaking of the asteroid into pieces from Gold Basin is, I think, 15 million years ago. I think. Don't quote me. Don't go writing this up or anything. But longer ago, but probably about 15 million years ago. So for a long period of time, there was a smaller asteroid wandering around the asteroid belt that eventually became a near-Earth asteroid, and eventually 15,000 years ago ran into the Earth, or the Earth ran into it, depending on who was going faster and what direction they were going.
The smaller
Wait,
meteorites that are, say, the size of a basketball.
That's not a small one, but yes.
Yeah, but are they cracked or anything?
Are they what?
You hear on TV about, it's the size of a school bus or a Volkswagen, and it might hit, it might not, but the smaller than a Volkswagen, are those tracked?
Better now than they used to be, yes. So there are a lot of people who are monitoring. You just go out and see a fall occurring, so a fireball, whatever it might be, and so they start coordinating the visual observations. But also there are people who have developed programs to use weather radar. And so you can track these things with weather radar, and yes, you can track them back to primarily the main belt asteroids.
Two questions.
Okay.
One, you indicated that this particular
Meteorite, or that's on the ground. Asteroid in space or meteoroid in space, meteor in the atmosphere, which is the glow of light, and meteorite on the ground.
Well, when it was a meteor and
Okay.
it exploded,
Correct.
what would cause it to explode?
Have you ever done a belly flop?
Yes.
Okay, so you have something that's going 40, 50 kilometers a second, which is probably faster than you drive on I-10 by a little bit. It basically hits the atmosphere, and there's a lot of atmospheric pressure.
Okay.
And in fact, the glow you see, and I got this wrong for 30 years, the glow you see of a shooting star or whatever it might be is bow shock. It's this thing coming through the Earth's atmosphere really, really, really fast, and you heat up the air because it can't get out of the way, and it's that pressure is very, very large, and it's what basically breaks the thing up.
Okay. Last November, I was out in our backyard and I happened to see a shooting star.
Okay,
And I was very fortunate to see it split into two. One kind of curled
Oh,
off,
gee.
and the other one kind of went, it didn't take the straight line, it kind of angled off.
right.
And I thought, wow.
Yeah, I would, yes, wow, sounds,
Yeah,
I
wow.
would go along, I wish I had seen something like that, but yeah.
So my second question, of all these meteorites that have been found, have there been any elements that we don't know what they are? Are they all iron? Are they all, I guess.
The elements are the same elements that we have here. There are some rare or unique minerals that you will find in these things, simply because, like, the iron, nickel in the back there, yes, you would find that on the Earth if you had a drill that you can go down to the core of the Earth. So there are minerals in the meteorites that you don't see on Earth, but it's the same elements because the Earth is made out of them.
Gotcha. Well, I guess we can make that assumption that all the planets are made out of them, and
Yes.
if you found something that we didn't know about, then perhaps there's a planet out there that we don't know what's
Well, you're still, I think, we've been studying the Earth, we've been studying planets around other stars. And we think we know how, again, you're getting out of my field of expertise, of how the elements were formed. And so it is unlikely that you would end up finding any new elements in any of these things, because any of the really, really heavy elements are probably radioactive and would decay into something else very quickly.
Thank you.
But don't quote me on that one.
Thank you.
Yeah, and then I'll get you.
You
Oh.
made a very interesting comment that all of those samples that you found went to the Smithsonian. What made the samples that went to the Smithsonian different than the ones you had?
When the field was first discovered, the university told us that the Smithsonian somehow needs to obtain samples of all the meteorites that are found at that time. That's what we were told. And so they sent them a whole shoebox full, and one Jim found the size of a big baked potato that, he hated to send it. It wasn't ours, it was the U of A's that were going to maybe give it back to us, but we didn't know. But so we found out later that none of these have actually been on display at the Smithsonian, because I know it's a big deal to change a museum display, yeah. So, and then also we had to get permission to hunt near the lake because it's called the Lake Mead National Recreation